Hello, this is Keith Graham from Codasip. I'd like to introduce you to Assignment 11, Adding a Custom Instruction. Now let's first look at the RISC-V architecture. Now, there are 6 basic tenets that this architecture was developed on. They can be found in the RISC-V Reader by David Patterson and Andrew Waterman. The first tenet is it should be suitable for all sizes of processors, all the way from a very small embedded controller to a general purpose processor that you could find in your notebook to a high performance compute node that you might find in the cloud. The second tenet is it must work well with a wide variety of software stacks and programming languages. The third tenet is it must accommodate all implementation technologies, from an FPGA to different technology nodes in semiconductors. It must be efficient in its design for the microarchitecture styles and support different microarchitectural styles as well. The fifth tenet is a very important tenet, which is allow extensive specializations to act as a base for customized accelerators. This is the tenet that we're going to be focusing on this assignment. And the sixth tenet is stable base instruction set architecture that should not change. We should be able to be confident that we develop our design and code on a base architecture and it should not change. But once again, this assignment of adding a custom instruction is focused on the fifth tenet, which is allow extensive specialization to act as a base for customized acceleration. Now, if we look in detail of the RISC-V architecture, the lower 7 bits is the base opcode for each instruction. There are 4 of these base opcodes that have been left available or allocated for customization. So the user or the developer of a processor can develop custom instructions for acceleration. In this assignment, you will be adding a custom instruction. You will be developing a new base opcode from one of these 4 locations to accelerate the bubble sort algorithm or program. In designing a processor, there are many goals that you can be designing towards. One is the smallest area to save costs. Another one might be the least amount of power to increase battery life, or as in this assignment, is to complete your application as quickly as possible. You will be taking a look at the bubble sort program. You're going to profile it and find in an instruction pair, which are 2 instructions next to each other, that if I can collapse those 2 instructions into one, therefore I would reduce the number of instructions that I have to complete. Now, if we take a look at the computer architecture algorithm in terms of deciding or calculating the application time, it is total number of instructions times cycles per instruction divided by processor frequency. Now, if I assume that my cycles per instruction is constant and my processor frequency is constant, but I reduce the total number of instructions to execute, my application time will decrease, and therefore I will have accelerated the application. That's what you'll be doing in this assignment. Good luck!